Hi, welcome to our part 4 program of our NLP. What we have seen in our previous class is how to define a logistic regression model and how the mapping function looks like in logistic regression model and how the cost function looks like in logistic regression model. So during the current class, in the part 4 of this class, what we are going to see is basics of NLP. So the NLP denotes natural language programming. The classical models, usually the logistic regression and linear regression and any type of classification model, usually it uses the numerical data. So all the inputs given to our mapping function is in the form of numerical input. So in our earlier example, like predicting the house price and whether it is going to rain or no rain, all the informations are the numerical values. So in house prediction problem, it would be size of the house, number of bedrooms, and the location of the house. Here in weather prediction model, it would be like wind speed and temperature, humidity. All those values are given as an input numerical values. But in natural language programming model, the difference is all the informations are in the form of text. And the model natural language processing models uses all the textual information and derive the meaningful output. So what is the need for the NLP models? So here in the internet world, we know that around 5 billion users are on the internet. Could you imagine the 5 billion users on the internet? This is actually 63% of the entire world population. So now we know the how big the internet industry is. So within 5 billion, we see around 4.4 billion users are on social media platforms. And this covers around 59% of the entire world population. So now we can realize how big this social media industry. So one of the biggest social media industries, we all know that it's Facebook. Now when we look at the volume of data collected by the social media industries, it is around 2.5 quintillion of bytes every day. So you know this how big the number is. It is 2.5 into 10 to the power of 18 bytes. So this is the size of the data being collected every day. Now we can realize that how big this social media industry is and the volume of information being collected by the social media industries. Now, what is the use of the data collected by the social media industries? We know that the weather forecasting model is built um, by observing the weather information. This is the observation world. So by looking at the weather information, we can come up with the weather forecasting model. By looking at the market of the housing prices, we can come up with that house price forecasting model. So we can look at any type of information available in the world and we can build a model. Now we have a huge volume of text information created by us, the users, all textual information. So when we observe this entire information, what we can do is we can come up with so many models that can be useful for the marketing industries and advertising industries. So what is their goal, marketing and advertisement industries? They just want to know what these people are looking for. They just want to understand the demand of the people and what is their need, what they are thinking about the products. their sentiment about the service or product. So they want to understand what the industry that what the world is looking for, and this marketing and advertising company just to try to understand their thinking process or their need or demand and trying to provide what they want. So can yeah, so this can be done by building some NLP models. So NLP models can be built using this text information collected from social media or any other online platform, and then we can come up with that any kind of classification or regression model. A simple example would be a sentiment analysis. So the sentiment analysis, what it would be trying to do is just understand the user's review. Maybe we can just look at that review of movies. uh, uh, Let us assume that the information given to this sentiment analysis model is all movie reviews. So and then see whether the movie review is a positive review or negative review, whether it has the positive sentiment or negative sentiment. So for an example, one reviewer has written that I liked the movie, it was awesome. So the sentiment associated to this movie is positive. You can see in another example, I did not like the movie, it was boring. So the reviewer too for the same movie. So the sentiment of the second movie is negative. So when we have all these kind of reviews, we can collect all the reviews related to a given movie and come up with that input data, and then we can process this input data, come up with an NLP model, and then NLP model would predict for any given movie review whether the movie review has the positive sentiment or negative sentiment. So the goal of this NLP model is to process all the textual information and come up with any classification model or any regression model. So we all know that computers can process only the numerical values, but here in NLP models, all the information what we are providing to the model is in the form of text. So next, now the steps involved in building the NLP model is converting this text into a numerical format. So what all we need for building a model f of x theta, is that correct? That what we have seen so far is this is our mapping function. Mapping function needs x and thetas. The theta will be generated or um, maybe created using any optimization algorithm, that is the popular algorithm is gradient descent algorithm. So in order to define this mapping function, we need this x. X is a numerical value. How we can convert this text into numerical value? So that is our next step. So we will see how we can create a numerical value derived from the textual information. So can you think of any methodology to convert this text into numerical value? Yeah. So the simplest way is just digitize that information as a binary value. So here all the textual information that is provided for the model, we can call it, this is generally call it as corpus. So whenever you see this word corpus, it means either document or this observations, the observations of the world. So here the corpus, for this given sentiment analysis example, has all the movie review, set of movie review. Let us assume that there are M movie review, 1, 2, 3, 4 up to M. And each movie review has its outcome, whether Y. Y is either positive sentiment or negative sentiment. Here in this model, what we are trying to do is we are trying to create this X features. This is called as feature engineering. So the next step is feature engineering or data processing. Here we need to come up with some kind of x1, x2 up to xn. How do we define from this text information? The simplest method is just read all the text, come up with the vocabulary. So the vocabulary would have unique list of text. For example, in the previous example, what we saw is I saw I liked the movie. It was awesome. And another review says that I did not like the movie. It was boring. So when we look at these two review, how do we create the vocabularies? This vocabulary has I liked the movie. It was awesome. Not boring. So the unique words, entire list of unique words in this entire corpus is called as vocabulary. So now the size of, what is the size of this vocabulary? 4, 5, 6, 7, 8, 9. So the size of the vocabulary here is 9. So then by using this vocabulary list, we can create an input feature. So just each word in this vocabulary would be considered as a X value. Like here in this vocabulary, we can create feature X1 as I, X2 as liked the movie. It was awesome, not boring. Now we are in the process of creating the feature. For the first data point, this is for the first observation 1. Uh, this is called as x1, this is called as x2, x3, x4, x5, x7, x8, and x9. Then we just look at this word and look at the movie review and see whether the word is appeared in that movie review or not. Know that the word I is appeared in the first review, so we will give value 1. Liked is also available in the first movie review. So it is 1, this is also 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 1. Not available in movie review, not available in movie review. The second one, this is 0, 0, this is 1. I was common to both. And this was 1, this was 1, this was 1, this was 1. Not available, this was 1, this was 1. So likewise, we can create the mapping and this kind of encoding. So we can encode the textual information and come up with this format. Now we have all input information in numerical format, and for each observation, observation 1, observation 2, up to m observation, we have all this x vector, x1, x2, x3, x9, and we have to find out what these theta values are, theta 1, theta 2, up to theta 9. Then we can predict our y prime, whether the movie has a positive sentiment or negative sentiment. So here so now we have converted the textual information as a regular numerical information, and it looks like typical our logistic regression model what we have seen in our earlier class. So the only difference between NLP model and typical logistic regression model is just this data pre-processing. We need to prepare the data such that we can apply this logistic regression model and then come up with the prediction. So that is the only difference in NLP model. We don't need to get scared that when somebody says that, oh, I have come up with the NLP model, natural language processing. So the main difference is the data pre-processing. Now, so we have seen this method, that how we can create this mapping, encoding of the textual information. So can you see any issue with this data creation? Can you look at and see, would there be any issue in this way of creating the mapping? So just think of a minute and see. Yeah, so I can give you an answer. Yes, definitely there is an issue in this mapping format. So I have just given you a two sentence and just came up with x9. But in real world problem, the word number of words or the corpus could be very big. Maybe the review number of reviews could be 500,000 or 200,000 or 300,000. Okay. So when we build the vocabulary, the size of the vocabulary could be so huge, maybe 100,000 words. So when we have 100,000 unique words, how big the data size, the size would be, the input matrix would be. So we need to create a very big input data matrix, and our input vector would be of size 100k for a given one observation, x1, x2 up to x 100,000. And how many parameters we need to tune? Yeah, that is a very big challenge, that theta 1 up to. So for a given small classification model, we need to train our model in order to tune this 100,000 thetas. So it would be consuming a lot of our computer power. It takes longer time to train and build our model. So how we can avoid this big data issue? The simplest way is actually reducing the dimension. So yeah, so how we are going to reduce this input dimension? We will see that in our next class. Till then, yeah, wait for our next session. Thank you so much. Bye.